Hello everyone and welcome back to the series where we are building a Roblox game using ChatGPT 4 to do all of the scripting with some help from me, but not very much. Now in the last episode, which was the first episode, we started getting used to how to build with ChatGPT, and we put together a basic scene and we added a basic animation for swinging a pickaxe, and that's pretty much where we left it off. So it was mainly just like an introduction to how we're going to be doing things. And I actually did a little bit of stuff off camera. I kind of made this is the area that we had in the last video, but I just kind of expanded it a little bit so we had more space. And yeah, that's pretty much it. So I will just talk to Charlotte here and just get her to introduce herself again. Charlotte is the AI who is helping me build this game. Okay, Charlotte, we started the second episode of the series. Can you introduce yourself to anybody who has not met you yet?
Hello everyone, and welcome to the second episode of our series. I'm Charlotte, an AI assistant here to help Fizz in the development of a mining simulator game in Roblox Studio. For those of you just joining us, we're combining Fizz's extensive game development experience with the latest advancements in AI to create an engaging and functional game. Let's dive into today's development tasks and see what we can accomplish together.
And so you can see in the first episode, I actually had the ChatGPT window kind of, in a small area in the corner, but I figured that was probably hard to see. So I'm going to try my best to remember to switch back and forth between the window when I'm talking to Charlotte. And yeah, that's basically it. So in this episode, we want to add some mining nodes and see if we can get them to be mined, basically. So essentially what we want is just to have a node that spawns, and we want to be able to mine it, and we want it to be able to be removed from the game world. So let's get started right away, and let's get Charlotte to give us the first snippet of code. Okay, Charlotte, so in this episode, we want to get some basic mining functionality. So as you remember in the last episode, we had a script that lets us swing our pickaxe, but it doesn't actually do anything yet. So we want to take that script and actually make it so that it can mine a node that has spawned in the world. Can you give us a script that lets us mine a node?
Certainly, Fizz. To enable mining functionality, we need to expand the pickaxe script so it can interact with a mineable node in the world. Here's a basic approach. Identify mineable nodes. Assign a consistent identifier, like a name or tag, to your mineable nodes. For example, you could name them mineable node or use a special object value as a tag. Script modification. Modify the pickaxe script to detect when a mineable node is within reach and apply mining logic. Here's a script that implements basic mining functionality. In this script, a Raycast is used when the pickaxe is activated to detect if there's a mineable node in front of the player. Adjust ray direction's magnitude to control the mining range. Workspace. Mineable nodes should be a folder containing your mineable nodes. Ensure the nodes are named or tagged consistently to identify them as mineable. When a mineable node is hit, you can implement logic like reducing its health or changing its state. This part is commented out and should be replaced with your specific game logic. This script is a starting point. Depending on your game's design, you might need to add more complex logic for node health, player inventory updates, and visual audio effects. Let me know if you need further details or assistance with this part of the game.
Okay, so there you have it. So she gave us a script that we can update our previous script with. And that script, I believe, was right here inside the pickaxe. And we just want to go into the pickaxe script. So essentially, we just want to replace everything in here. And so we have member whitelist is deprecated. Oh, okay, that's not good. So she probably doesn't know what the new version of this code is. So I'm just gonna have to look it up probably. Or we can ask her. Hey Charlotte, in the code that you gave me, the third line where you say enum.raycast filter type.whitelist, that's telling me that it's deprecated.
If enum, Raycast filter type, whitelist is showing as deprecated, you can use an alternative method to set up the Raycast parameters. In Roblox, Raycasting can be done by specifying which objects the ray should hit or ignore. Instead of using a whitelist, you can directly set the filter descendants instances property of the Raycast params object to include the specific objects you want the Raycast to detect. Here's the revised script.
Turns out that enum.raycast filtertype.blacklist is also deprecated.
Thank you for pointing that out, Fizz. We can use the updated method for raycasting without specifying these filter types. In this case, the Raycast params object's filter descendants instances property alone can be used to define which objects the ray should interact with. Here's the updated script without using deprecated filter types.
Okay, so she finally gave me some code that doesn't have deprecated stuff in it. So we can try running with this, but I'm going to set up the actual node now, and based on like what she said. So I will do that and then we'll be right back. Okay, so I put a node here, a copper node, just again from the free assets. And I did what she said. I put a Mineable Nodes folder on the workspace. And now we're just going to make sure that the folder is correctly named in here. Oh, right, we need to actually change the name. So let's see. Yeah, workspace.mineable nodes. Now this name should be, I changed it to copper ore. So let's call this copper ore and save it. And then, I don't know, let's just run it and see what happens. Like I'm putting full trust in her. I'm not really checking to see if things are working properly or whatever. So, okay, so here we go. So this is my pickaxe. Now if I, oh, the mining isn't working anymore. Oh, you know what? Oh, I know why. Okay, hold on. Because I blindly copied her code, and it turns out that the actual animation is not there anymore. Let's see. Let me back up. Let's back up all the way. Oh yeah, because I have the whole animator stuff in here. And she kind of took all that out. So you know what we need to do? Let's just back up here to where we had that. I'm going to feed her this code, and I'm going to tell her that we need to update this code and not, you know, give me the new code. Not give me the code that she gave me. So let's do that. Let's flip back over here. So Charlotte, the code that you gave me replaced the code that we had previously that had all the animation stuff in it. So I'm gonna give you that code, and I want you to take your script and combine it with my script to make it all work together. All right, let's see what she comes up with here. I didn't specify, you have to be very specific with ChatGPT prompts sometimes.
To combine the mining functionality with the animation and debounce logic, we'll integrate the Raycast and mining logic into your existing script. Here's how it can be done. In this combined script, when the tool is activated, the script first checks if enough time has passed since the last activation, debounce logic. If the debounce condition is met, it performs a raycast to detect if there's a mineable node in front of the player. If a mineable node is detected, the script applies the mining logic, E, G, reducing the health of the node, and then plays the animation. The animation will only play if the player successfully hits a mineable node and the debounce time has elapsed. Make sure to adjust Raycast params. Filter descendants instances to point to the folder or collection of mineable nodes in your game. Test this script to ensure that both the mining action and the animation play correctly.
Okay, so it's not working. Okay, so I had this whole segment where I fixed the problem, but it turned out that I was actually in this browser view the whole time. So I'll just summarize what I did. So I was trying to figure out why it wasn't working, and I figured that it was probably this, the range here was not correct. So I changed it to 25 just to test it, and I added some print statements here to see where it was not, where it was kind of, which if statement it wasn't getting to. So it was running this one, but it wasn't running this one. Now it's running both of them, but the problem still is that it's not doing the animation. So let's just run this, and I'll just show you guys what's happening now. So I take out the pickaxe and see if I get close enough, then it's doing the raycast, right? But like if I'm, way out here, it still does it. And I think. So I don't know, it's a little finicky. So we might maybe want to try doing this with proximity potentially. Like it's not doing the animation for some reason or other, and I'm not actually sure why. I'm sure some of you who are watching know exactly why, but like I said, I'm not familiar with Roblox syntax. I've programmed in other languages before, so I can get around figuring out like debugging and stuff, but I'm gonna leave it to Charlotte to try and guide me through this, and that's kind of the whole point of this series anyway. So let's go back over here and let's tell her what's going on. Oh, and the other thing that I figured what the issue probably is that in the code we have the check is seeing if you hit the node and if the node is a base part. Now the nodes here are not base parts, or the node is not a base part, it's a model. Alright, so I tried mucking around with this a little bit more and it's just not working the way that I want it to, so let's just try a different approach. So I'm gonna go back to talking to Charlotte here. Okay, Charlotte, so the whole Raycast thing just isn't working properly, so can we just go back to the drawing board with the original script and make it use like hit detection instead?
Understood, Fizz. If raycasting isn't fitting well with your game's mechanics, another approach for hit detection is using proximity-based detection. This method checks for nearby mineable nodes when the pickaxe is swung. Here's a revised version of the original script to include proximity-based hit detection. In this version, the script includes a function, getNearbyMineableNodes, to find mineable nodes within a certain range, mine range, of the character. When the tool is activated, it checks for nearby mineable nodes and applies mining logic to each one within range. The mining range can be adjusted to fit your game's design. The proximity check is based on the distance between the character's primary part and the primary part of each mineable node. The mining action and animation play only if the debounce time has elapsed. Remember to adjust workspace, mineable nodes to the actual folder or group where your mineable nodes are located in the workspace. Test the script to make sure it works as expected with your game's setup.
Okay, thanks Charlotte. Is this going to work with the fact that the mineable node is a model? The first mesh part in the model is actually the primary part, so how can we set that to be the one that's being checked in the hit detection? Attempting to index node.
If the mineable node is a model and its first mesh part is set as the primary part, the script can be adjusted to specifically use the primary part for proximity detection. The primary part property of a model is used to represent the main part of that model, so it's suitable for checking distances in hit detection. Here's the modified script to use the primary part of each mineable node model for proximity checks. In this script, the getNearbyMineableNodes function checks the distance between the player's primary part and the primary part of each mineable node model. It assumes that the primary part of each mineable node is correctly set to a meaningful part, like the first mesh part. The script then applies your mining logic to each nearby mineable node within range when the tool is activated. Make sure each of your mineable node models has a primary part set. You can do this in Roblox Studio by selecting the model, choosing a part in the model to act as the primary part, and then setting it in the Properties window under Primary Part. This script should now correctly identify and interact with nearby mineable nodes based on their primary part's positions.
Okay, so I briefly forgot how to set the primary part, so I just asked her and I figured it out. We did do that in the first episode, so I should have remembered, but I didn't. So there we go. So now we've set the primary part to be this part here, which is at the actual node. So now if we run this, I think we're still going to get that error, but let's see. Every time we try and swing the pickaxe, it seems to... Oh, now it's working. Okay, so we go over here. There we go. Now it's mining. Sweet. Now, it's kind of being a little weird with the way it kind of bounces me off, but I think it's okay. So we mine the node. So now that's working. So what we want to do now is let's just set this to disappear as soon as you mine it. So assuming that it has basically like a health of 1. So, and then we can adjust that after. But let's actually get Charlotte to give this script like a health variable, and then we can go from there. So, okay, perfect, Charlotte, that worked. So now what we want to do is we want to modify the script so that the mineable node has health. And we want that health to be a variable that we can change. Can you add that to the script?
Certainly, Fizz. To implement health for each mineable node and make it a variable that can be changed, you can add a number value to each node to represent its health. Here's how to modify the script to include health logic. Step 1. Adding health to each node first. Manually add a number value to each mineable node model in Roblox Studio. Select a mineable node model in the Explorer. Right-click on it, choose Insert Object, and then select Number Value. Name this number value as Health. Set its value property to the starting health amount for the node. Repeat this for each mineable node model. Step 2. Modify the script now. Update the script to decrease the node's health when mined. In this script, when the pickaxe is swung near a mineable node, it checks for a health number value and reduces it by mining damage. If a node's health reaches 0 or below, you can add logic for what happens when a node is depleted, e.g., remove the node, spawn resources, etc. Adjust mining damage to change how much health is reduced per hit. Make sure each mineable node has a health number value set appropriately. This script will handle reducing the health and can be expanded to include effects or changes when a node's health is depleted.
Okay, so while she was talking about how to do the how to add this value, I actually did add it in there, and then the mining damage right now is 10. Let's bring that down to 1, and the mining range is fine. So now it should. Before it was 10, so it was, you could see in the output that it was actually changing it by more than what I would have wanted. So now we go like this and we mine it, and the node is depleted and the health is 0. If we change this health to, let's say, 5, then we need to hit it 5 times for it to actually deplete. So let's see. 1, yep, 3, 2, 1. Oh. Okay, I wasn't in range, I guess. There we go. So now you want to go back to Charlotte and tell her to remove the node once this has happened. So let's see what she says about that. Charlotte, you're amazing. That worked. So now what we want to do is we want to remove the node once the health reaches 0. Can you update the script to handle that? And while we're at it, can we also have a variable for the player that keeps track of how much of that node they've mined? So we want to know what kind of node it is. For example, if it's copper, then when the node is mined, we want to add 1 to the player's copper. Okay, this is kind of a doozy, so let's see if she can figure out how to do all this at once.
Great to hear the previous steps worked well, Fizz. To remove the node once its health reaches 0 and track the resources the player has mined, we'll need to update the script accordingly. We'll also add a mechanism to keep track of the player's resources. Step 1. Player's inventory. For keeping track of the player's inventory, one approach is to use a folder or a table in the player's player object to store this information. For simplicity, I'll use number value objects within a folder in the player's player object. Manually add a folder to the player's object in Roblox Studio. Name this folder as Inventory. Step 2. Update the script now. Update the script to handle node depletion and update the player's inventory. In this script, the update player inventory function is added to update the player's inventory when a mineable node is depleted. When a node's health reaches 0, it is removed, node, destroy, and the player's inventory is updated. The inventory uses the node's name to determine the resource type. Ensure your mineable nodes are named appropriately, like copper, iron, etc. This script assumes that the player's character is linked to their player object. Adjust the inventory management as needed to fit the design of your game. Make sure to test the game to ensure that the nodes are removed correctly and the player's inventory is updated.
Okay, so I just quickly changed the name to copper. I just want to make sure that it still works even though I changed the name. So we'll go over here. Yeah, so that still works. Okay, and then she said to add a folder to, I'm assuming she meant players, not player. So I'm just going to assume that. And she said that, so let's check the code here. I'm going to copy the code and bring it over here so we can just kind of work in one area. And okay, now she made the mining damage 10 again, so let's reduce that back down to 1. Okay, so let's check the code here. Okay, so if the inventory name is inventory, then that's all fine. So we're checking player find first child inventory. Let's just see if that actually works. Oh no, this is the update player inventory. That will get called after. So everything else needs to work first. Should be fine. Okay, so copper and then resource count. There was one more thing that we had to do, right? When a node's health reaches 0, it is removed and the player's inventory is updated. The inventory uses the node's name to determine the resource type. Okay, so that should be fine. Let's just check to see what happens. So okay, let's just change this. Let's just change the health to 1 so it's easier. Okay, and then we want to, okay, so this part is working. If health value is less than or equal to 0, then update the player's inventory. Okay, and then with the node name. So let's see if this is actually firing. Update player inventory. So we want to go inventory name. Okay, so let's print this. Pop that in there. Now this should work. Boom, we have 1 copper. Okay, so that works. Now if we copy this node, let's duplicate it. Now eventually we're gonna have these spawning, through code and not hard placed in the world, right? So, but this is just for testing purposes. So let's move that node, like, I don't know, over here. Oh, let's move it over there, and then let's give this a try. Okay, so we break this one. Now we have 1 copper, and now we have 2 copper. Amazing. So that all works. We want to have an inventory UI to show what the player's inventory is going to be. That's going to be a much bigger step. So that's probably going to have to happen in another video. But I think for this video, we're pretty good. So we managed to add the mining capabilities here. And of course, like I said, this is still very simple. We're going to expand this to be more game-ish. Right now, it's just, it's working the way it works, but we need to obviously expand this to be more interesting. So let's get Charlotte to sign us off here, and then we will continue in the next one. Okay, Charlotte, so that all worked great. In the next episode, we're going to go one step further and have an inventory UI that shows us how much we have in our backpack. So can you sign us off on this video?
Absolutely, Fizz. I'm glad to hear that everything is coming together smoothly. And that's a wrap for this episode. We've successfully implemented mining mechanics and inventory tracking in our game, laying the groundwork for an engaging gameplay experience. In our next episode, we'll take it a step further by adding an inventory UI, bringing a visual element to our players' hard-earned resources. Thank you all for watching and joining us in this game development journey. Stay tuned for more updates and progress in the next episode. Goodbye for now.
Yes, indeed. Thanks for watching, everyone. Please join the Discord, drop a like, and subscribe if you haven't already. The Discord link is in the description of the video, and we will see you in the next one. Goodbye.